So let us look at swap 2 int star px int star py. Okay, and then of course I am doing the print. Maybe I'll write this alone, %d comma x equal to %d, y equal to %d, right, comma star px star py, and then underscore asm, right. And what am I doing here? Here I am doing push px, push py, pop px, pop py, right. And then I am doing the printf again out here, right. So let me just copy that, and then I am done with this, right. Now in my main, what am I doing? I have int x comma y. Okay, so here I am going to do, again I am going to do the prints, of course I will not write that, swap 2 of %x %y. Okay, this is how the function swap 2 has been defined. So if you come here and look at this implementation in main for the call to swap 3, right. So where is that function? Swap 1 is here, after that your swap 2 is here, right, and then you are going to basically do. Okay, so first of all, you note how the %x is implemented first of all. Okay, let's focus on this %x. So what is %x? It's actually the address, the offset address of the variable x on stack. Okay, so let's again look at the picture of the stack here. Okay, so that we can discuss it more concretely. Okay, my EBP is pointing somewhere here. Okay, so when I enter my main, okay, when I enter this point, EBP, main has run its prologue, push EBP, move EBP comma ESP, then subtract ESP comma, all that it has done, right, and then ESP is sitting somewhere here. ESP is sitting here. Okay, so EBP is sitting up, is pointing to this location, right, and what you basically have is, this is my main and this is value is 40. Okay, and I am going to say this is y main, this is 60, right. I think this is how I did it, right. X is going to, yeah, good. So therefore EBP minus 4 is basically going to be x and EBP minus 8 is going to be y. Okay, this is how it is. I will just check if this thing also has been defined like that. EBP, okay, actually the program here seems to have done it the other way around, but that doesn't matter. Okay, or maybe I'll stick to that notation, right. The compiler could assign it anyway actually. So I'll put x here in main, which value is 40, this is y and this is also this is 60, I am sorry. So EBP minus 8 is x, right, and EBP minus 4 is actually y. So what you have is, yeah, right. So now how do you get %x? Actually %x is nothing but this EBP minus 8 or EBP minus 4. Whatever the EBP in, when EBP is pointing to the value sitting in main. Okay, so it's basically going to get the EBP minus offset thing. So the instruction that is going to give you that is this LEA instruction. So I told you that you can actually do EAX, comma, EBP minus 8. This will just evaluate EBP minus 8 and put it into EAX. This will translate to EAX equal to EBP minus 8. Okay, and then you are going to push this onto the stack. Okay, so that is what is going to happen when you do this swap 2 of ampersand x and swap 2 of ampersand y. That's why you look at the assembly call here to swap 2. You do LEA into EDX, EBP, remember underscore y, right? This underscore y is nothing but 8, minus 4, sorry, here, right? So therefore, when you do the call to swap 2, you are going to do EBP minus 4 into EDX and push that onto stack. Then EBP minus 8 into EAX and push that onto stack. So therefore, what will get, so let us say this address, right? I will call this as X address, some value, okay, not the bracket. This I am going to call it as Y address. Okay, so now what you do, this call here will translate to push of, after doing the LEA, you will push the register EDX and EAX, right? So therefore, what will happen is, you will do push the Y address first, right? And then you will do push of X address here, right? And then you are going to call the swap 2 function, and therefore whatever return address, that is basically the stack cleanup address, add ESP comma 8 will happen, right? That is what, so return address main, whatever that return address is, right? So that's where then your ESP will point to this point when you enter the swap 2 function. Okay, ESP will be pointing here. What do you do? The first thing you do is to push EBP of main onto stack, right? And then you are going to move your EBP up. So EBP will then made to be point here, right? And then ESP will be subtracted out so that you get local variable space for the function swap 2. So this was what will happen after the prologue of swap 2 is executed, right? Now what you are going to do is, you are going to go ahead and print, of course, you will print 40, 60. Why? Again, very important. What we have now done is, we have pushed the address of this x and y. So we have star px, star py. These values are actually being sent. The addresses of x and y are being sent on the stack, are being passed by value. So pass by pointer is actually passing address by value. Okay, so the address is a value which is being pushed onto stack, and then you are dealing with those addresses completely, right? So in some sense, what we are going to do now is, when you execute this printf, right, what will happen is, you will effectively use this address, x underscore address, move it into a register, right, and then you say contents of EAX, whatever, you push it onto stack, and that's how you can do the printf. Okay, so effectively through this address you will access x, through this address you will access y, effectively. So after EBP, so in x address, this is EBP plus 8, this is EBP plus 12. These are my function parameters px and py. So when you do star px, you will load, you go back and see the printf call here, right? to inside the swap function. Inside the swap function, what are you going to do here? I am going to get, so you look at this, move EAX, EBP comma, this PY into EAX, and then contents pointed to be by EAX will be moved on into ECX and then pushed onto stack. Likewise you are doing similar for the X value star PX, right? And then you are going to call the printf. So now what you are going to do is, when you come here and you push PX and push PY, what is going to happen? On the stack, you will be pushing this X address and you will be pushing this Y address. Now when I do pop PX, pop PY, it will pop the top of stack where? To the address pointed to by this guy, and that is pointing to this EBP plus 8, and therefore Y address, so of course the thing will happen. So this will effectively now become, no, I'll keep the bottom one, yeah, this will become Y underscore address. So in EBP plus 8, the value of Y address has got written, and of course the stack pointer will come back here. Then you do another pop, the contents of top of stack, which is X address, will come here. So X underscore address. So what has got swapped now? Again, like the earlier case in swap 1, where the function parameters X and Y got swapped, here the two addresses star of PX and PY as function parameters have got swapped. So PX is now pointing to Y address, PY is now pointing to X address, and therefore when you go ahead and do this star PX star PY, you will obviously get the reverse value, 60 and 40 you will get appropriately. However, remember, no change has been made in the main yet, okay, and that is where the problem is, okay. That's why this swap function also has not been successful in implementing what we wanted, okay. So now let's jump into the third function, swap function. Basically swap 3 of int star px int star py, sorry, right? And what am I doing? I'm doing my print x equal to %d, y equal to %d, star px comma star py, okay. And then I do underscore ASM, and I do two important things here, move EAX comma PX, move EBX comma PY, and then I do push dword pointer of EAX, right? And let me make a copy of this and just, right, so this is EBX, this is just pop, okay, and then I do again a second printf. Here, okay, and in my main, what do? I do int x equal to 40, y equal to 60, and then I do my prints, whatever, and swap 3 of ampersand x ampersand y, and then my print again. Okay. So, print printf. Okay. So, now again we will look at the picture of the stack. Okay. Okay. So, let us look at this. This is where my EBP is in main. This is where my ESP is pointing after the prologue has been executed in the main, right? And I am going to do x on top, x 40, y 60. Okay. So, now what you do when you see this swap here, what will it do? It will do the LEA operation again, right? You will do LEA EAX comma EBP minus 8, then push EAX, then LEA EBX comma EBP minus 4, then push EBX and call swap 3. Okay. So, effectively what is going to happen, like I said, I am going to call this as my Y address and this as my X address. Okay. So, remember that this value of X address, Y address is not relative, it is not EBP minus 4. Whatever that value is, it gets evaluated and that will get pushed onto stack or whatever. Okay, remember that. So, this X address, Y address is not always EBP minus 4. When EBP changes, that will not change. That is a fixed address that we are talking about. That value is getting pushed onto stack, right? So, now what will happen? You will push the Y address onto stack. Then you push X address. Okay. And then of course the stack pointer ESP keeps moving, and then you call the return the function swap 3 return address onto main. What is the return instruction? The add ESP comma 8. Okay. So, when you execute the prologue of swap 3 again, the EBP main, that is this value. This is actually EBP main. Okay, that gets pushed onto stack, and then you are basically going to move your EBP here. This is my EBP now after this thing, and then you subtract out some space for local variables. So, ESP will be pointing here. So, when I enter this point to print, ESP is here. Again, through this X address, Y address, you will print the value of X and Y, which is 40 and 60. Now, what are you doing? I am doing something slightly different. I am taking the value of Px. Okay. Now, what is Px? Px is actually this variable here, Py, and this is basically given by contents of EBP plus 8. This is contents of EBP plus 12, right? So, I am taking that value EBP plus 8 into this thing, into a register. So, if you look at the register contents after this instruction, EAX will have the address of this local variable Px. Okay, it is going to have the you are going to have so what you are going to do now is, oh no, you are going to, sorry. So what you are going to do now is, when you move EAX comma PX, you are moving the value of what is in this variable, right? That is this X address and Y address. So after these two instructions, EAX will have X address and EBX will have Y address. Okay. Now what are you going to do? You are going to treat these as addresses and do contents pointed to by EAX. Contents pointed to by this X address is this guy. Contents pointed to by this Y address is this guy. Right? So what will you do? You will push the D word pointer pointed to by EAX, that is the value of this thing, into the stack here. This will become 40. Okay. ESP will then move up. Then you push contents pointed to by EBX, which is Y, sitting in main, 60. Now what you are going to do? You are going to pop the top of stack to contents pointed to by EAX. What is EAX pointing to? X address. And therefore, now at this point, you will see that this 40 becomes 60. And the stack pointer increments again by 4. Then you do another pop and this 60 will now become 40. Okay. Thereby, what we have done now is, effectively we have been able to swap the values. So once you finish executing this instruction of swap 3, the values in main themselves have got swapped. Okay. And note that there is no swapping of values here this time. These two don't get swapped, right? They don't get swapped because of any operation. Earlier till now, the function parameters themselves were getting swapped. None of that is happening now. It is only this X and Y sitting in main that is effectively getting swapped always, right? Now you come out of this function, you print the same thing, star px star py, you print and you finish and you come out. When you come out of swap 3, right, and you come back to main for the last printf, the X and Y in main themselves have got swapped, and therefore you will get 60, 40 as the answer out there. Okay. So this is very, very interesting because we have been able to, actually what we have done in this implementation is to do star px. How do you do star px? You move the px value. Star px means use px as an address and get the value pointed to by that address. So you move px into a register and then do dword pointer pointed to by the register. You will get the data from that pointer. That's how pointers are themselves operated on in C, right? So what we have effectively done nicely in this program is to do, effectively, if you want me to encapsulate this into a pseudo code, I would say we have done push star px, push star py, right, pop star px, pop star py. But this is pseudo code, okay, because this thing doesn't translate to an actual assembly instruction in the microprocessor x86, right? Therefore, that's why I'm saying it is pseudo code, right? Effectively, we have done this operation, right? So with that, I would like to say that pass by pointer, right, itself is actually passing an address by value, but I think it still warrants a different name. It's not passing by value, or it's not a misnomer, because passing by pointer, you are not making a copy of that variable, right? When you pass by value, you are making a copy of that variable on stack. From the main, you are making a copy of that variable in some other location on the stack, right? And that's why that's called pass by value. Pass by pointer, the address is not sitting in any variable. You are just creating a new parameter that has that address, and therefore it warrants a different name, and that's why it is called pass by pointer. Interestingly, in C++, you have this thing of passing by reference. Okay, you can do int ampersand x. So when you define a function in C++, you can do int ampersand x, int ampersand y. Okay, and then you can do the same operations here, whatever function you want. And in main, what you can do is you can just define it as int x comma y and swap x comma y. You can call it like this, swap x comma y, but because this is ampersand, you are calling by reference, internally the assembly code is identical to what we do with passing by pointer. You will actually pass the pointer of x and y and deal with all the values of x and y as pointers inside that function swap also, right? This is an aside, this is in C++, so I will not get into any demonstrations for this purpose here. Okay, so finally I would like to conclude by coming back to one of the initial points that we had made, right? What we actually wanted to do, right? If you look at that, I also wrote some pseudo code, right? I wanted to do push star px or push star py, pop star px, pop star py. Okay, this is what we effectively implemented, and this, if you look at it, it translates to push contents pointed to by px, push contents pointed to by py, pop contents pointed to by px, pop contents pointed to by py, right? This is what we, this statement effectively means. If you take the pseudo code and you want to make it an assembly instruction, this is what it would mean. Take the value of px, use it as an address, contents pointed to by px, go look at that location and then do the push and pop. You will swap exactly like this. This is what pointers are, right? Why does this not work in a microprocessor like x86? Now we know the answer, because we have seen what px and py themselves are. Px and py are what? These are function parameters, which means px itself is contents pointed to by EBP plus 8 and py is contents pointed to by EBP plus 12, which means this effectively will translate to push contents, double contents of EBP plus 8, right? Push double contents EBP plus 12 and then pop and pop, same thing in the same order, double contents. Unfortunately, this kind of an instruction does not exist in the microprocessor. What does this mean? It means take the value of the register EBP, add 8 to it, then use that as an address, go to memory, fetch that value. Now use this value as an address and again fetch. So this is like a double pointer operation that we are trying to implement in memory, and this is very, very, very expensive, and it is not wise to even implement such instructions in a microprocessor. Okay, you may think it's it seems like a very complex thing that is being done very simply, but it is not a good idea to implement such complex instructions in a microprocessor like this. Okay, and for that reason, in fact, it may not even be possible to do that in a single clock cycle, right? You might need multiple clock cycles and all that, but therefore I'll just leave it at this point, saying it's not a good idea to even think of such implementations. We will later discuss the ramifications of trying complicated instructions in hardware and see what effect it has on the clock frequency and so on, right? But in summary, I would like to now conclude by saying that local variables, function parameters are all values that are stored on stack. You call functions using mostly by pass by value or passing an address by value, right? And effectively that way you will be able to implement anything and everything in C programming very effectively.